Cryptocurrencies and NFTs are two of the hottest noisemakers today.
NFTs are roaring back. $1 million or more
Behind
every
both
day.
these technologies, we see the common buzzword, blockchain, which has enabled the rise of these industry disruptors. But what exactly is blockchain? In this video, we'll take a deep dive to understand what blockchain is, how it works, its applications, and why it may be one of history's greatest inventions. To put it simply, blockchain is a decentralized way of recording and monitoring any set of information. It's a record-keeping method that can be accessed by everyone. Blockchain collects data chronologically in the form of groups called blocks. Blocks have a specific storage limit, and once this storage limit has reached its capacity, that block is closed and is linked to previous blocks, therefore forming a chain of information, or blockchain. Blocks protect each other in a creative way. To learn more on that, here's what's inside a block. Every block contains 4 key information: its data, its hash, the hash of the block before it, and its proof of work. Let's take a closer look at these one by one. First is data. Data depends on what the blockchain system is used for. For an e-wallet app, it can be used to record the data of a transaction, to track the sender, receiver, and the amount transacted. Next one is the hash. Hash is like the key representing the data. It is used to prevent tampering inside a block. Hashes are generated depending on the data that's recorded inside the block. Data and hashes are partners, and whenever an edit in a block's data happens, a change in its hash will instantly occur. Since data and hashes are tightly coupled, any changes that occur will create a reaction of one another, and it will be immediately detected. This way, the hash and the data of a block coexist to protect each other. The third information inside the block is the hash of its previous block. So block 4 knows block 3's hash, block 3 knows block 2's, and block 2 knows block 1's. The first block in the chain is the only one that has no data about its previous block's hash because, well, it's the first one. It is called the Genesis block. If a tampering occurs in an old block's data, its hash will change. Then the newer block will detect it because they have the copy of the legit previous hash. The succeeding blocks will react, and the tamper will get invalidated. However, supercomputers nowadays can compute thousands of hashes per second. So what if someone tampers a block's hash and then proceeds to tamper all of the hashes of the succeeding blocks in one go? Here's where the fourth content of a block comes, and it's called proof of work. It is a complex calculating task, similar to a puzzle, that is required in order to add a new block to the chain. Yes, you can add a new block and own it by calculating its proof of work. This process is called mining. In the case of Bitcoin, it takes 10 minutes on average to calculate a block's proof of work. Proof of work slows down the addition of new blocks. It makes it harder to tamper older ones. If you want to tamper an old block, you have to tamper its hash and redo its proof of work. You then have to tamper all of the succeeding blocks' hashes and redo all their proof of works too. So far, we've learned about blockchain's strong security that comes from the co-protection of data and hashes, plus the delaying mechanism from proof of work. However, there's still one more layer of security, and it comes from decentralization. Blockchain is not managed by a single entity. By the use of a peer-to-peer network, blockchain allows its users to manage the system. When someone joins a blockchain's P2P network, they receive a full copy of the blockchain. Every user has the same record, and this is monitored by validators called nodes. Nodes are devices that supervise the records in a blockchain network. Here are the 3 things that nodes do. Number 1. Nodes store the blockchain's transaction history. They keep track of all the block's data in the network. Number 2. Nodes broadcast and spread their transaction history to other nodes so that they all synchronize with the blockchain. They all update simultaneously when new data is provided. Lastly, nodes are responsible for accepting and rejecting transactions. Since all nodes have the same record, they use their data to consult each other for validity. For any change in data to happen, it needs to be approved by more than 50% of the nodes. The Ethereum network, for instance, has more than 300,000 nodes. If a bad actor tries to attack it, they will have to control more than 150,000 nodes. And these nodes are spread across the globe. Unlike traditional database systems that have centralized keeping, decentralization makes blockchain strong against power outages, systemic crashes, and bad actors. To successfully hack a block, a hacker will need to tamper all the succeeding blocks next to it in the chain. The hacker has to recalculate all of the block's hashes, redo the proof of work for all those blocks, and take control of more than 50% of the P2P network. That's the only way for a tamper to be validated. Here's a quick summary of what we've learned before we get to some real-life uses. Blockchain is a data recording system. It uses blocks to store data chronologically. Blockchain uses hashes, proof of work, and decentralization to protect its integrity. Now let's take a look at how a leading retail store uses blockchain to provide better service to their consumers. Walmart faced a large-scale issue of refunds due to the return of products that have poor quality. At first, they were unable to detect the point of failure in their supply chain, which goes a long way from the farm to their storage to transporting and processing before it finally reaches their consumers. Then, they started using blockchain. Because of it, they were able to track the quality of each goods in every stage of their supply chain because it gets permanently recorded within a block. And if, for example, employee Satang dropped one of the boxes and wanted to hide the damage, he won't be able to easily do so because a record of every single product was already written within blocks. To tamper that, he will need to tamper millions of other individual products that were listed in the blockchain network. This helped them permanently fix problem areas, mitigating repetitive causes of returns. The blockchain innovation heightens the integrity and recording of data, and it generates trust without the need for a third party. This eliminates extra fees from intermediaries and provides faster and more secured way of transacting. It prevents loss of data, tampering, and technical issues that are commonly faced by banks, e-wallets, and other third-party processing firms. More and more companies are adopting the blockchain system. The integrity that blockchain provides will continue to revolutionize how every set of information is recorded in our modern society. Licenses, IDs, or passports, for example, can be recorded in blocks to prevent identity theft. Real estate titles can be tracked to provide the highest level of security for its ownership. Illnesses and their causes can be securely recorded to grant anonymous access for researchers to help find cure. Copyright can be permanently inscribed, and many more applications for financial processes, history tracking, and electoral voting that requires the highest level of fidelity. Now that we've learned about the basics of the blockchain and its importance, we've set the foundation on how to adapt and monetize from it. However, blockchain is just a part of a bigger picture that the decentralization of the internet or Web3 is bringing. So be sure to subscribe to receive more valuable lessons here in BTech 3.
Web3 content for all.